We are going to consider this problem from different aspects. I will tell you 10 important ideas. I'll leave 3 homeworks, and the identities or ideas are, for example, this one. You should draw unit circle. After some problems, you can imagine general formula when you have sine x equals sine y. Also for cosine, cotangent, tangent, we have these. If you want to learn them, you can send message to my WhatsApp number. Concerning small examples, so much powerful. In all years of AMC, AIME, USAMO important. Getting good at this idea is so much important. Next one, Legendary's formula for finding power of p in n factorial. I will explain all of these things during solving this problem. Idea 5, multiples of a in 1 to n is what? Considering mods. Idea 6, then I tell you some identities, identity 7, 8, 9, 10, and you can solve the problem of AMC 12, 8, 2023 with these ideas. Okay, if you want to learn more ideas or want to solve more homeworks, more related problems, or want to learn 40, 50 important ideas and formulas in each topic, combinatorics, algebra, number theory, and geometry, feel free to send message to my WhatsApp number in the description. Find the number of pairs m and n of positive integers with 1 less than or equal to m less than n less than or equal to 30, such that there exists a real number x satisfying sine mx plus sine nx equal to 2. Okay, so we know sine of an angle is between what and what? Sine of alpha is between -1 and 1. So because this sign plus this sign equals 2, so both of them should be equal to 1. Okay, because maximum of first one is 1, maximum of second one is 1. And you can consider both of them should be 1. Now, we want to see what can we conclude if sine mx equals 1. One thing in problems related to trigonometry is to draw unit circle or trigonometric circle. After, for example, solving some problems, you can imagine that. Okay, so if we draw this, we know vertical line is for sine. And when sine is 1, it means this angle, only and only this angle. So we can say if sine alpha equals 1, then alpha equals what? Pi over 2 or 90 degree, this one, plus 2k pi. Because if you add 2k, it will be same. And we can say k should be integer. Because we have this, 1 was so much easy, but sometimes we have general part, for example, sine x equals 1/2, and you want to find all angles. It is so much important. When we have sine x equals sine y, the formula is that y equals x plus 2k pi or pi minus x plus 2k pi. These two answers, and k is an integer. Okay? So here you say it is equal to sine 30 or pi over 6. So x equals pi over 6 plus 2k pi or pi minus pi over 6, which will be 5 pi over 6 plus 2k pi, which k is an integer. Okay. For cos also we have another formula. For tan and cotangent we have other formulas. Here, for example, if you want to apply these, you say, okay, sine pi over 2, sine alpha equals 1 equals sine pi over 2. If you use this formula, alpha equals pi over 2 plus 2k pi and pi minus x. Pi minus pi over 2, again it will be pi over 2 plus 2k pi, okay? So both of them will be one answer. Now we found this for mx and x. You can apply idea 2, or here the thing that we've written here, you can apply and see mx is what, nx is what. So try the rest, pause the video and try the rest first on your own. Okay, let's write this part. Sine mx equals 1. Let me write with other color. Sine mx equals 1. So we can say what? By this part, this idea, mx equals pi over 2 plus 2k pi, which k is an integer. Also sin nx equals 1. So we can say nx equals pi over 2 plus, for example, 2l pi, which k and l are integers. K is an integer, l also is an integer. There exists k and l, that mx equals this, nx equals this. Now, I want to divide both sides. Why? Because I can cancel x, I can cancel also pi. So if you divide mx over nx equals pi over 2 plus 2k pi over pi over 2 plus 2l pi. Okay. Now in next step, I cancel x, and why we can divide? Because x is not 0. Why? Because if x is 0, sine 0 will be here. 0 plus 0 will be 0, not 2. And also we know this part is not 0 because it's pi over 2 plus 2k pi. And it cannot be 0, also this part, so we can divide. And here we can divide both numerator and denominator by pi, so we can conclude m over n equals 1 over 2 plus 2k over 1 over 2 plus 2l. Now for second fraction, for this fraction, I multiply both numerator and denominator by 2 to get rid of this denominator. So it will be 1 plus 4k, 1 plus 4l. Or we can write 4k plus 1 over 4l plus 1. And we know m and n are what? M less than n, less than or equal 30, greater than or equal 1. We should see we can write how many of these m and n's in terms of this. Try this one again, pause the video and try the rest first on your own. For this part, lots of, at first try on your own, and I think 90% you will have careless mistake. Let me tell you something that is so much important, and decrease number of careless mistakes is what? Considering small cases or small examples. So much powerful. But it's important that you get good at applying this. So here, for example, let's consider different m and n. 1 less than or equal m less than n less than or equal 30. For example, let's consider m is 1. Okay, m is 1. I want to see which fractions are good. 1 over 1, because m is 1, n is greater than 1. So n, we can start from 2. 1 over 2. It's not good because you cannot write it like this. And as you can see, here it is odd, odd. Odd over an odd numbers. So we can conclude all 2's from m and n will be cancelled. So power of 2 in m and power of 2 in n should be equal. Okay, and let me show you the symbol is what? V2. V2 of m equals V2 of n. VP of a number, VP of, for example, t is power of t, power of p in t. Okay, for example, V2 of 24 is what? If you prime factorize V2 of 2 cubed times 3, power of 2 is what? Because we said V2 is 3. Okay? Now we can conclude, because it is odd, odd, V2 of m equals V2 of n. Okay? And because I've told you V2 and VP, let me tell you an idea useful in some problems of AMC. VP of n factorial. Okay, it has a formula. We can call it, it's called Legendry's formula. It is what? It is n over p floor of n over p plus floor of n over p squared plus floor of n over p cubed and so on. Okay? And the proof, let me tell you, the proof is what? For example, when you want to find V2 of 13 factorial, you say, okay, it is 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10 times 11 times 12 times 13. This sign is floor, okay? For example, when you say floor of 2.4, you should round down. It is 2, or floor of 2.9 is 2. Now, I say if I want to use this formula, it says 13 over 2. 13 over 2 means what? Let me tell you idea 5. If you want to see from 1, 2 to n, how many multiples of a are there? Number of multiples of a, it will be what? It will be floor of n over a. Okay, this formula n over a, so 13 over 2 will be what? Even numbers. 13 over 2 is what? 6.5. Floor of that is 6. So how many even numbers? 1, 2, 3, 4, 5, 6. It is calculating even numbers. Next one. By this formula, we calculate 13 over 4. It is multiples of 4. So this one, this one, this one. We are calculating 4, 8, 12 again. Next one, 13 over 8, multiples of 8. It is 1, this. And after the 13 over 16 floor of that will be 0. And the rest will be 0. So it will be 6 plus 3 plus 1. So it will be what? 10. And if you want to calculate power of 2, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we are calculating each number same as power of 2 in that number. Okay, so it will be 2 to the 10 times something. Okay, it is one formula related to VP of n. And look, we don't want to solve only this problem. We want to consider from different aspects, and I tell you important ideas that may be useful in, for example, in other problems of AIME and other exams. Okay, so when m is 1, we say 1 over 2 is not good. We said V2 of them should be equal. So next one, we should check 1 over 3. Can we write 1 over 3 as 4, for example, k plus 1 over 4l plus 1? 4k plus 1 over 4l plus 1. If we cross multiply, it will be 4l plus 1 times 3 times 4k plus 1. And if we consider mod 4 on idea number 6, when you want to solve a problem, consider mod. Okay? It's so much useful. Here we should consider mod what? Mod 4. If we consider mod 4, left hand side is what? 1, right hand side is 3. Contradiction. So 1 over 4k plus 3 is like 3, not possible. So we can say 1 over 5 is good. 1 over next one, 6, 7. We said we should only check odd numbers because V2 of m should be V2 of n. Because m is odd, n should be odd. 1 over 7, again, like 1 over 3 bad. So we can conclude 1 over 5, 1 over 9, 1 over 13, 1 over 17, 1 over 21, 1 over 25, and 1 over 29. These numbers are good. 1, 2, 3, 4, 5, 6, 7. Okay, here we have 7 good numbers. Now let's consider next one. Suppose m equals 2. So 2 over a larger number. We said V2 of m equals V2 of n. Okay, V2 of n, power of 2 in n equals V2 of m. Here we said, okay, we can call it a star. So by star, we have this. Now V2 of m is what? M is 2, so power of 2 is 1. So power of 2 in n also should be 1. So the first even number that we should check is 2 over 6. Is it good or not? Can we write it as 4k plus 1 over 4l plus 1? If we cross multiply again mod 4, this one will be 2 mod 4. 6 times 1 will be what? Will be 6, which is 2 mod 4. It was a necessary condition, mod 4. We've not reached any contradiction, but if we consider mod 8, here 2 times 4, 8l. 8l will be 0, mod 8. 2 times 1 is 2. 6 times 4, 24k. Mod 8 is 0. 6 times 1 is 6. 6 mod 8 is not 2 because 6 mod 8 is a remainder. It's because then the difference should be multiple of 8 should divide 6 minus 2, which is 4. But 4 is not multiple of 8. So we reach contradiction for 2 over 6. Now let's check next even number. 2 over power of 2 in denominator should be 1. So after 6, we should check 8 is bad because power of 2 is 3. 2 over 10. Okay, you can write it. You can, if you cancel, it will be 1 over 5, and we will see. Okay, that's good. Okay, because 4k plus 1, 4k plus 1. So 2 over 10 is the first number that is good. Next one that we should check, 2 over what? 2 over 14. Again, we can use same thing. 4k plus 1, 4l plus 1. If we multiply, it will be 2 mod 8, 14 mod 8, so 12 multiple of 8. Again, like this, if you apply, you can do it as homework 1 so much easy. Contradiction. Okay? Next one, 2 over, so 2 over 10 is good, 2 over 14 bad, 2 over 6 was bad. 2 over 18 again similarly will be good because it's 1 over 9. And again, by same way, you can say 2 over 22 is bad. 2 over 26 is good. 1 over 13. 4k plus 1, 4l plus 1. And next number, 2 over 30, again will be bad. Okay, we can check also this 1 over 11. Maybe you say, okay, 1 over 11. If this one is 4k plus 1, this one 4k plus 3, it will be bad. But you should also prove that we cannot multiply these things by any number to reach 4k plus 1, 4l plus 1. So one way is to consider mod 8. Okay, so by considering mod 8, you can prove this. So for 1, how many good numbers did we have? 7. For 2, what are the good numbers? 2 over 10, 2 over 18, 2 over 16. 2 over 10, 2 over 18, 2 over 26. 3 fractions. Now let's consider 3. If the numerator is 3. If we have 3, it is m over n. M is 3 in this case. And we are considering what? 3 over first number. We know m is less than n, and n should be odd, okay? So let's see 3 over which numbers are good. 3 over n should be greater than 3, and n should be odd because v2 of m equals v2 of n by star. So because m is odd, n is odd. 3 over 5. Is it good or not? Again, if you write it as 4k plus 1 over 4l plus 1, and you multiply, you cross multiply it, and consider mod 4. Then 3 is congruent to 5 mod 4, which is wrong because 5 is 1 mod 4. Okay, so 3 over 4k plus 1s are bad, but 3 over 7, is it good or not? It's good. When you want to say it's good, you should find it is equal to which 4k plus 1 and 4l plus 1. It is equal to, if you multiply by 3, 9 over 21. Okay? 3 over 7 is good. 3 over 11, 3 again over 4k plus 3s are good. Why? Here you say 9 over 33. Maybe you say, okay, 33 is greater than 30. We know that m and n should be less than or equal to 30. Yes. This 9 is 4k plus 1 and 33 is 4l plus 1. M is 3, n is 11. We proved that there exists k and l that satisfy this equation, okay? So L and K can be any integer. M and N should be in this range, okay? So we can conclude which numbers are good. Similarly, 3 over 5 was bad. 3 over 7 is good. 3 over 11 is good. 3 over 15 is good. 3 over 19 is good. 3 over 23 is good. 3 over 27 is good. And okay, last one. So how many good numbers? 1, 2, 3, 4, 5, 6. Now next one is what? Next one is 4. 4 over which numbers? Again, v2 of m and n are equal. Here m is 4. 4 over n. We know n is greater than m, greater than or equal to 1, less than 30. And v2 by star. v2 of n equals v2 of m equal to 2. Because power of 2 in 4 is 2. So the first number we should check is 4 over 8. No, 12. Is it good or not? It is 1 over 3. And if you want to write it 4k plus 1, 4l plus 1, we can reach contradiction. Let me... 1 and 3 are not equal mod 4, and you can guess it's not good. And if you want to prove, complete proof, for example, maybe it is a problem in USAMO, you should prove completely. Okay, here we can say what? We can say, if we cross multiply 4 over 12, 4 times 4l, 16l, plus 4 equals 48l, plus 12. And if we consider mod, what number can you guess to reach contradiction? Mod 16. Here 0, 4. 4 is congruent to 0, 12 mod 16. So we can conclude 12 minus 4 is multiple of 16. 8 multiple of 16. Contradiction. Or you can say 4 and 12 are not congruent mod 16. So 4 over 12 is bad. Next number that you should check 4 over 16. And no, because v2 of 16 is 4. 4 over 18. Let me check 4 over 16. Sorry. 4 over 20. 4 over 20 is 1 over 5. Okay? And you can check. 4 over 20 is the first number that is good. Next one, if you check 4 over 24, the v2 is not equal to 4 over 28. Again, you can reach same contradiction. 4k plus 1, 4l plus 1. If you cross multiply and consider mod 16, then 28 minus 4, 24 should be multiple of 16. That's a contradiction. So for 4, only 4 over 20 is good. One case. Okay? Okay, now similarly, we can check next numbers if m is 5. So again, we should divide 5 by odd numbers. 5 is exactly similar to 1, okay? So for 1, we said 1 over 5, 1 over 9. Let me copy this part. And I want to say for 5, it will be what? If you consider this, you can say, because n should be greater than m, you can say, let me erase these things. And it will be 5 over 9, 5 over 13, 5 over 17, 5 over this, 5 over 25, and 5 over 29. Okay, they will be 4k plus 1 over 4l plus 1. So, if we consider 1, 9, these numbers, 1, 9, 13, 17, 21, 25, 29. If we consider each of them, 1, 9, 13, 17, 21, 25, 29, they are good. So 1 with how many of them? 1, 2, 3, 4, 5, 6. And let me check. Also we have 5. 1, 5. So if we write, we said what? 1 over, sorry, 5 and 1. We said 1 over 5, 1 over 9, 1 over 13, 1 over 17, 1 over 21, 1 over 25, and 1 over 29. These numbers are good. Next step, we can start from 5. 5 over 9, 5 over 13, 5 over 17. We found the pattern. 5 over 21, and we proved that this pattern is good. 5 over 29, good. Next one for 9. 9 over 13, and to 9 over 29. And last one is what? Last fraction, 25 over 29. These fractions are good. So here is 7, 1, 2, 3, 4, 5, 6, 7. Next one, 6. 1, 2, 3, 4, 5, 6. Next one is 5. Next one is 1. So it will be 1, 2, 7. Or we could say 7 choose 2. Okay? 7 choose 2 is 7 times 8 over 2. 7 times 4, 28. Or you can say 1 to 7. So here, how many ideas? They tell you idea 5, idea 6, idea 7, identity 7. Let me write. When you have 1, 2 to n, it will be what? It will be n times n plus 1 over 2. So here we can say sum of them is 1 plus 2 to 7 equals what? 7 times 8 over 2, which is 28. Also, you should memorize some identities. For example, these two identities were useful in AMC 12A 2023. We had a problem related to something like this, 1 cube minus 2 cube plus this. You could solve it with two ways. One way is to use second this identity n squared, which will be n times n plus 1 times 2n plus 1 over 6. Identity 9 is to use 1 cubed plus 2 cubed to n cubed equals n times n plus 1 over 2 whole squared. Okay, so try to do this one as homework. I think it will be homework 2 to solve this problem of AMC 12A 2023 with two solutions using identity 8. So by applying identity 8, one homework, solve this problem by applying identity 9. It was 1 cube minus 2 cube. The last one was something like this, 17 cube minus 18 cube. And it says it is equal to what? Okay, and if you want to apply identity 8, you should also know identity 10, which is a cube minus b cube, or in general, a to the n minus b to the n is what? Which is a minus b times a squared plus ab plus b squared. And in general, an minus bn is what? A minus b. Can you guess? It is what? An minus 1 plus an minus 2b. 2, you should decrease power of a by 1, power of b increase by 1, n minus 1. Okay. Now, for 1, 5, we found this approach. For 3 also, you can say same thing, 3, 7. These numbers are good. So you say 3, 7, 11, 15. These numbers are good. So let's write them. Okay, so let me copy. Okay. For 3, you can say 3, 7, 11, 15, 19, 23, 27. So it will be 1, 2, 3, 4, 5, 6, 7. Let me check. Oh, sorry. Here we should say 8 choose 2. Okay, 8 choose 2, which is 7 times 8. Let me correct also this part. 8 choose 2. And it is equal to n choose 2 is n times n minus 1 over 2 if you simplify. And here, 1, 2, 3, 4, 5, 6, 7. It will be 7 choose 2, which will be 7 times 6 over 2, which is 7 times 3, 21. Okay, now let's consider the cases that we are working with even numbers, okay, like 2 or 4. Here it was what? We said 2 over 10, 2 over 18, 2 over 26. Why these numbers were good? Because 2 over 10 is 1 over 5 when you simplify. 2 over 18 is 1 over 9. Look, 4k plus 1 over 4k plus 1. 2 over 26 is 1 over 13. This. Now, so you will see if you multiply 4k plus 1, 4l plus 1 by 2, then you can reach these things. It means what? For example, for 1. We know that if you consider 1, I want to multiply them by an even number. For example, look, 4k plus 1, 4l plus 1 times 2 to the a. Here also 2 to the a, okay? So I can multiply first one. Let's consider, for example, 2013. You can multiply it by 2. You can multiply this one by 2, but this one by 2, this one by 2. You can multiply 5 by 4. And 1 by 4, you can multiply 1 by 8, but if you multiply 8 by 5, it will be bad, okay? So, because you can multiply these numbers by 2, so 2 times 1 is what is 2, 2 times 5 is 10, 2 times 9, 18, 2 times 13, 26. So we know that 2 over 10, 2 over 18, 2 over 26 is good, 10 over 18, 10 over 26 are good. 18 over 26 is good. Okay, so again, we can say 1, 2, 3, 4. 4, choose 2, which is 6. Okay, for this one, we can do the same thing. You can multiply this one by 2, this one by 2, this one by 2, this one by 2. You can multiply this one by 4, this one by 4. Okay, so for this part, because we said 4 choose 2, also you can say 4 times 1, 4 times 5. 420. 420 again, it will be good because 4 over 20 is 1 over 5. It's good, so it will be one case. Now for these parts. 2 times 3, 6, 14, 22, 30. So we can say what? We can say 4 choose 2, 6. And next, 4 times 3, 12. 4 times 7, 28. 12 over 28 is good because it will be 3 over 7. 4k plus 3 over 4k plus 3, we know is good like this because you can multiply both of them by 3. And it will be 9 over 21 and it's good. And it will be 1. So let's add these numbers. 28 plus 21 is 49. 49 plus 6, 55. 55, 56, 62, 63. So our answer will be what? 63. Okay. It was one problem related to these ideas. I've told you one homework, homework 1, homework 2, homework 3 from AMC. Let's see how many ideas did we consider. 10 ideas and 3 homeworks. Okay, so in this problem, we've considered 10 ideas and 3 homeworks. I've left. If you want to solve more homeworks or want to learn more ideas, 40, 50 background ideas, want to get good at problem solving, want to learn ideas in combinatorics, algebra, number theory, and geometry, feel free to send message to my WhatsApp number in the description. Okay.